All right, greetings everyone. Welcome to the first part of the video for section 2.4. We're going to look at kind of an application of linear functions, ones that helps us deal with real-world data. Okay, so to kind of motivate this, here we have a graph of some data that relates the distance of a flight to the amount of airfare. So for example, here it looks like that if we look at like this data point here, it's telling us that for a flight of distance 400 miles, the price would be about $460 from Baltimore, it looks like. Or for this one up here, it looks like if we're looking at a flight of about 1,200 miles, the price looks like that's probably around $260. Okay, and you might notice that all this data, all these points we have lined up here, they don't form a perfectly straight line. However, hopefully you would agree with me that their shape is kind of linear. They kind of look like they might form a line, or a line could be used to approximate some stuff here, right? Okay, so that brings us to the idea of what is called a line of best fit. Or sometimes you hear this referred to as a regression line. So a line of best fit is a straight line on a scatter plot that comes closest to all of the dots on the graph. And important, a line of best fit does not always and does not have to touch all of the dots. And what it allows us to do is to understand the type and the strength of the relationship between the two sets of data. So in our case, it's the relationship between distance and the price of the airfare. And then it also allows us to use X and Y here, but allows us to predict missing output values for given input values. And sometimes we can also do the opposite, find missing input values given output values. Okay, so going back to this set of data here, okay, we're gonna draw a line of best fit here. Now, a couple of things about the line of best fit. Number one, we generally try to make it so that it splits the data evenly, so there's about the same amount of dots above and below the line. But then the other thing is it needs to follow the trend of the data, and here's what I mean by that. So, for example, if I try to draw this line here as my line of best fit, well, note it more or less splits the data, right? There are 4 dots up here and 5 dots down here. So it has split it evenly. However, does the slope of that line in particular follow the trend of the data? No, right? Because from left to right, the data is going up, or the dots are going up, whereas my line from left to right is going down, so that won't work. So we need to instead draw a line that follows, again, the data. I'm going to try my best to do this. I think maybe we could do something like that. Okay. And notice now that's following the trend of the data. And with that, I have, looks like 4 dots above, 4-ish dots below. So I split the data pretty evenly. And so this is probably a good guess at a line of best fit. And as mentioned, what this allows us to do is to make some predictions about things we don't have data for. So for example, at 1,400 miles, a trip of 1,400 miles, notice if I go up the graph there are no dots there, so we don't actually know what the airfare is for a flight of 1,400 miles. But we can guess based on our line. So if we look at the point corresponding to 1,400 as an input on our line, it looks like it's about $240. Okay, so that's why these are useful. Now, another thing about line of best fit, if you're making predictions like what we just did, okay, you want to try to stay within the confines of the data you're given. So here's what I mean by that. If you look at let's say we want to make a prediction about the price of a flight that was, say, 4,000 miles. Okay, well, as you notice, based on the way I drew it, right, 4,000 miles has nothing to do with the data that we are looking at here. So in that case, we would not want to make a prediction about the price of a flight of 4,000 miles. However, say like 300 miles, we could use, so 300 miles right about here, make a prediction there, because that falls within kind of lowest and highest values of data we have. Okay? All right, so the next part of this in the next video will be to see how to come up with a line of best fit, and a particular equation of a line of best fit, using technology, because it turns out we don't have to do this by hand. Our calculators, our graphing calculators in particular, can figure this out for us. All right, thank you for watching.